Every day, millions of people crack open an ice-cold Coca-Cola without ever imagining the massive operation behind that very first sip. And have you ever stopped to think that during the World Cup, this turns into a true industrial race? Factories run non-stop, trucks roll out fully loaded, stores build up inventory, and bars get ready for every decisive match. And the focus of this episode is not Coca-Cola's secret formula. The mystery here is something else. What happens between the water, the syrup, the carbonation, the bottle, and the electronic inspection? And how does the logistics chain work before millions of fans open a Coca-Cola while the ball is in play? Stay with me, because today you are going to discover that journey. Welcome to Factories and Facts. Today we are stepping inside a production line where treated water, massive tanks, pressurized gas, filling machines, sensors, and robots work like a perfectly timed choreography to deliver the same experience in every bottle. Before it reaches your hand, Coca-Cola goes through strict stages. The water is filtered and standardized, the syrup is prepared in large tanks, carbon dioxide is added at exactly the right point, and every package must receive the precise volume before racing down the conveyor belts at incredible speed. And all of this has to be checked in seconds. Cameras scan for label defects, sensors measure level and pressure, systems reject units outside the standard, and teams monitor every batch. One tiny difference can mean waste, delays, and losses in an operation built on precision. And if in our last episode about sweetened condensed milk, you saw how pressure, heat, and the exact right point transform milk into a creamy, standardized product, the industrial logic here is similar. Only now, the challenge is controlling water, syrup, carbonation, and packaging at high speed without letting a single variation slip through. So make sure you subscribe here to Factories and Facts, because today the question is simple. Which stage do you think is the most impressive? The beverage mixing, the high-speed filling, or the inspection system that catches invisible defects? From this moment on, we are going to follow Coca-Cola's path. And it all begins with the simplest and most important ingredient of all: water. It may sound strange, but Coca-Cola's first major star is not the sugar, not the carbonation, and not the famous concentrate. It is the water. Before a single bubble appears, before the bottle enters the line, and before the drink takes on its signature color, everything begins with a simple liquid that has to be treated with extreme precision. In a soft drink factory, water cannot simply arrive and go straight into production. It passes through filters, analyses, and purification systems that remove particles, odors, and variations that could alter the final taste. The goal is to turn an ordinary raw material into a stable, safe, and standardized foundation. And here is an impressive detail. For the consumer, a Coca-Cola has to feel familiar anywhere. Whether it is bought at a small grocery store, a busy diner, or near a stadium on World Cup Day, the experience has to be practically the same. That is why the factory treats the water almost like tuning a musical instrument. If one note is off, the entire composition changes. Minerals, acidity, purity, and sensory characteristics are monitored so the drink reaches the expected standard even before it receives the syrup. After this preparation, the water moves into enormous stainless steel tanks. From the outside, these tanks may look simple, but they work like the silent heart of production. Inside them, sensors track important parameters while automated systems control the flow going in and out. This is the point where many people imagine the factory begins working directly with the secret formula. But the industrial process does not need to reveal that secret to be fascinating. The real spectacle is in the scale, the precision, and the perfect repetition of every stage. The concentrate used in production arrives at the facilities through a controlled system. From it, the factory prepares the syrup that will be combined with the treated water. This mixture has to follow strict proportions, because even a tiny difference can affect thousands of liters of beverage. Imagine an ordinary kitchen, only multiplied to an enormous scale. Instead of a pitcher, massive tanks. Instead of a spoon, industrial agitators. Instead of one person checking the flavor, equipment, technicians, and sensors working at the same time to keep everything within standard. The syrup is prepared carefully because it carries much of the drink's identity. This is where the foundation of the color, aroma, and taste begins to form. And when we are talking about a brand recognized around the world, any variation has to be prevented before the batch moves forward. While one tank is being prepared, another may be ready to feed the next stage. At the same time, new batches of treated water keep arriving. The factory runs like a continuous gear system, where each section depends on the one before it to keep production from stopping. And during major events, like the World Cup, that synchronization becomes even more important. Demand rises, stores prepare ahead, bars build up their supplies, and distribution centers need enough product to keep pace with the rhythm of the games. A common mistake is thinking that the most complex part of Coca-Cola is only the secret behind the recipe. But inside the factory, the daily challenge is something else, repeating the same product millions of times with the same standard, without letting speed, volume, and demand pressure affect quality. Once the treated water and syrup are ready, they move into a controlled blending stage. The mixture has to become homogeneous, as if every drop carried the same proportion of flavor. Nothing can be too concentrated in one area or too weak in another. That is why the tanks have agitation and measurement systems. They help keep the mixture uniform before the drink moves ahead. It sounds simple, but think about the size of the challenge. Doing this not in a glass, but in volumes capable of filling thousands of packages. At this moment, Coca-Cola still does not have that bubbling sensation everyone recognizes. It already has the liquid base, the color, and the flavor profile, but it is still missing the element that completely transforms the experience: carbon dioxide. And it is fascinating to realize how much the gas changes everything. Without it, the drink would lose part of its refreshing bite, the sound when the bottle opens, and even that quick foam that rises in the glass. The bubbles are small, but they play a huge role in the product's identity. Before receiving the gas, the drink has to be in the right conditions. Temperature, pressure, and composition all need to work together. It is not enough to simply force gas into the liquid. Carbonation is a technical, controlled, and essential stage that guarantees the expected result. And if you are enjoying this look behind the scenes of the operation, go ahead and leave a like. It helps Factories and Facts keep bringing you industrial processes that look simple from the outside, but hide impressive machines, numbers, and decisions on the inside. What is most interesting is that everything so far has happened before the bottle even appears as the main character. The water has been treated, the syrup has been prepared, the mixture has been controlled, and each batch has been guided toward the next phase. Only then does production truly begin to gain speed. From this point on, we enter one of the most hypnotic parts of the factory. The stage where the gas is incorporated, packages arrive one after another, and the filling lines work at such high speed that the human eye can barely keep up. Now that the treated water and syrup have already been prepared, Coca-Cola is still not complete. It is missing the element that changes the entire experience: carbon dioxide. This is what creates the bubbles, the sound when the bottle opens, the quick foam in the glass, and that refreshing sensation so many people immediately associate with the drink. But carbonating a beverage on an industrial scale is not as simple as putting gas into a liquid. For the bubbles to reach the right point, the factory has to control temperature, pressure, and flow with extreme precision. If any one of these factors falls outside the standard, the result can change completely. Before this stage, the mixture may be chilled to make it easier for the gas to be absorbed. That happens because colder liquids can hold carbonation better. Then, the beverage passes through sealed equipment where carbon dioxide is incorporated in a controlled and uniform way. And this is where one of the most impressive parts of the factory begins. The beverage stops being just a mixture prepared in tanks and starts moving through a continuous line, where every second matters. From this point on, stopping production without a reason can mean delays, waste, and lost efficiency. While the carbonated Coca-Cola moves through the pipes, the packages begin to appear at a rapid pace. PET bottles, glass bottles, and cans may go through different systems, but they all have to follow the same principle: cleaning, positioning, filling, sealing, and inspection. In the case of bottles, they arrive one after another on conveyor belts, like an endless line. Some go through internal rinsing, others through blowing or preparation systems, depending on the type of package. The goal is to make sure they are ready before receiving the beverage. Then comes the filling. This is one of those scenes that feels almost hypnotic. Filling nozzles descend or line up with the packages. The beverage rushes in at high speed, and each unit receives an exact amount. Everything happens so fast that the human eye can barely follow it. What is most curious is that the machine cannot simply pour the liquid in any way it wants. Since the beverage is already carbonated, the filling has to respect the pressure to prevent excess foam. If too much foam forms, the volume can come out wrong and the package may be rejected. That is why industrial fillers work with precise synchronization. The package enters, is positioned, receives the beverage, moves on to sealing, and leaves the station in just a few moments. It is like a mechanical choreography, repeated thousands of times without losing rhythm. With cans, the process also demands speed and care. They need to be filled, closed, and sealed with precision to keep the gas trapped until consumption. A poor seal can compromise the product, reduce internal pressure, or cause leaks during transportation. With PET bottles, the cap becomes a decisive piece. It has to be applied with the correct torque, not too loose, and not tightened improperly. It may seem like a small detail, but this closure is what helps preserve carbonation until the drink reaches the consumer's refrigerator. And when we talk about the World Cup, that speed carries even more weight. Before a major match, supermarkets, bars, and restaurants need to be fully stocked. So each filling line becomes part of a much larger operation, one that begins in the factory and ends at game time. Imagine thousands of bottles moving down the conveyor while, across town, fans are already buying drinks to watch Team USA. Production does not see just one package at a time. It sees batches, shifts, orders, trucks, and tight deadlines. This is the phase that surprises many people. Manufacturing Coca-Cola is not just about ingredients. It is about motion. The factory has to transform liquid into packaged product at an astonishing speed, without losing control, safety, or consistency in each unit. And here is a question for you. Which package feels most perfect for game day? An ice-cold can, the classic glass bottle, or a 2-liter bottle to share with everyone? Comment below, and tell us your city and state too. I want to know where the Factories and Facts crowd is watching from. After filling, the product still is not cleared to move on to the market. Many things can go wrong along the way. A cap outside the standard, a dented can, an incorrect level, a crooked label, or even a small flaw that is invisible at a quick glance. That is why the next stage is one of the most rigorous in the entire factory. The freshly filled packages move into inspection systems that work at high speed, using cameras, sensors, and automatic rejectors to identify any unit that is not perfect. And this is an essential point. The faster the line, the smarter the inspection has to be. There is no use producing thousands of units if some of them reach the market with defects. Speed only makes sense when it comes with control. From this point on, we are entering the area where the factory seems to have electronic eyes. Every bottle, can, or package goes through a kind of silent test, where machines check details in fractions of a second before the product moves on to final packing and distribution. After Coca-Cola is filled, many people imagine it is already ready to head to the market. But inside the factory, a decisive stage begins. Inspection. Producing fast is not enough. Every bottle, can, or package has to prove in seconds that it is at the right level, properly sealed, and ready to travel without failing on its way to the final consumer. The human eye could never keep up with this speed. That is why cameras and sensors take over the mission. As the units move along the conveyor, systems check the liquid level, label presence, cap position, package integrity, and any detail outside the standard. The judgment happens in fractions of a second, without interrupting the main flow of modern production there. When a bottle has a problem, it is automatically removed. It may happen through an air jet, a side pusher, or another rejection mechanism. The line keeps moving, but that unit leaves the path. This detail helps prevent products with leaks, incorrect pressure, or crooked labels from reaching shelves on high-demand game days as well. Inspection also protects the carbonation. If a cap is applied with incorrect torque, the gas can slowly escape. For the consumer, that means a flat drink. For the factory, it becomes a warning. Something in the adjustment needs to be checked before the defect repeats across thousands of packages on the same fast-moving production line. Quality control does not begin only after filling. It follows the water, the syrup, the blending, the carbonation, and every package batch. Samples may be analyzed, indicators are monitored, and operators watch screens with real-time data. It is constant surveillance over a product that seems simple, but is manufactured on a scale many people can hardly imagine. After approval, the packages move on to grouping. Bottles become shrink-wrap packs, cans form multi-packs, and cases receive batch identification. This coding matters because it shows when the product was made, which line it passed through, and where it should go next. Without traceability, logistics becomes blind, and any correction loses speed exactly when total precision is needed most. Automation plays a major role in this phase. Mechanical arms, conveyors, and palletizers organize enormous volumes without breaking the rhythm. A poorly built pallet can tip over inside a truck. A poorly sealed pack can tear. That is why even the stacking has to follow standards, because the journey is still long before reaching stores, bars, restaurants, and full refrigerators on decisive game day. During the World Cup, this stage comes under extra pressure. The factory is not just working to fill ordinary shelves. It helps supply cookouts, watch parties, pack sports bars, and stores expecting buying spikes before matches. Every approved batch has to leave without delay. It is fascinating to think that, at this point, Coca-Cola stops being just a beverage and becomes industrial cargo. What was once liquid inside tanks is now in identified, grouped, and stacked packages. The factory turns flavor into inventory, inventory into orders, and orders into trucks ready to enter the next gear of this massive national distribution operation. And that is where the process changes scenery. The machines have already done their part: treating, blending, carbonating, filling, and inspecting. Now the race begins outside the factory. Now you're going to discover how Coca-Cola reaches stores before the games and meets millions of fans with an ice-cold bottle, ready for the first sip of the match. After passing inspection, Coca-Cola stops being just a beverage on the production line and becomes cargo. The shrink-wrap packs, cases, and pallets move to shipping areas, where each batch is separated according to destination, order, and delivery urgency. This is where the factory connects to another gigantic machine: logistics. Trucks need to leave on time, routes are planned, distribution centers receive enormous volumes, and stores prepare to restock shelves before demand rises on game days. During the World Cup, this movement becomes even more intense. Supermarkets, bars, restaurants, and convenience stores, no demand can surge close to match time. So the beverage has to arrive before the fans, before the cookout, before the watch party, and before the opening whistle. Think about it. The Coca-Cola someone opens to celebrate a goal may have passed through steel tanks, carbonators, fillers, inspection cameras, palletizers, trucks, and distribution centers before finally landing in a refrigerator. A simple sip hides an enormous chain. And that is the most fascinating part. The consumer only sees the cold bottle in their hand. But behind it, there is an operation involving chemistry, engineering, automation, quality control, and transportation on a gigantic scale. Nothing happens by accident when millions of people are expecting the same product. The curious thing is that during major sporting events like the World Cup, Coca-Cola is not just a consumer product. It becomes part of the ritual. It is in the store before the game, in the cup during the match, and often in the celebration after a goal. The factory works so that moment can feel effortless. So, by the end of this journey, the question is no longer just how Coca-Cola is made. The real question is, how does an operation this complex become almost invisible to someone who simply wants to open an ice-cold Coke and watch the game? Today, we saw that everything starts with water, moves through the syrup, comes alive with carbonation, enters high-speed packaging, faces electronic inspections, and only then heads to the market. Every stage exists, so the final experience always feels familiar. And if you enjoyed seeing what happens behind the scenes of Coca-Cola, subscribe now to Factories and Facts, because here we reveal the factories, machines, and processes that move the world. And comment below, which part surprised you the most in this Coca-Cola journey to World Cup game day? And if you think you have already seen everything, then you have no idea what factory we showed in our last episode. It is already appearing right there on your screen. Click it, and come with me to discover one more hidden secret here on Factories and Facts. A big hug. I'll see you there.